voice on our recordings. All right, so what we're going to be looking at here is taking derivatives of inverses. So there are going to be a couple ways that we can do this. So I'm going to work through sort of both ways, and we're going to look at the graph so that we can see, because depending on what information they give us, sometimes we can't just find the inverse. On something like f of x equals x cubed, we could just find the inverse, take the derivative, plug in 8. But we can't always do that. So I want us to think about how that works. So, like, if we were given this problem and they ask us for, this notation is a little bit weird here. It's f inverse prime of 8. Right? So this is asking us for the derivative of the inverse at 8. So I'm going to walk us through just the most simple way first, and then we're going to look at what we would do if we could not find the inverse. Okay? So we have f of x equals x cubed. So we could very easily find that inverse like we were doing last night, correct? So we could say x equals y cubed, and then we could cube root both sides. So y would equal the cube root of x, or we could write that as f inverse of x is, I'm going to go ahead and make it x to the 1/3. Okay, so it's asking me to find the derivative of f inverse at 8. So if I find the derivative of this, notation looks like this, f inverse, and then we put brackets around it and put a prime out here. That tells me I'm taking the derivative of the inverse of x. So if I take the derivative of this, I would have 1/3 x to the negative 2/3, which, since I'm going to plug a number into, I think I'll turn this back into 1/3x to the 2/3, which is 1/3 cube root of x squared. All right, so that's just basic derivative power rule there. And then it's asking us for f inverse prime of 8, so we would plug in 8. So we would have 1/3 times the cube root of 8 squared. You can do 8 squared and get 64 and take the cube root. That's a perfectly acceptable way of dealing with that. Or sometimes if you got bigger numbers here, this is also the cube root of 8 squared. Cube root of 8 is 2. 2 squared is 4. Either way is pretty easy to deal with here, but sometimes you get ones that are harder to deal with. So 3 times 4 will give us 1/12. Okay, so if you can find the inverse of the function, this is probably the easiest way to deal with it, as long as the inverse is not super complicated, right? If it was like the inverse that we get on number 39 from the homework, it's not maybe the easiest to deal with, but it's probably going to be difficult either way. But sometimes you may be given this information and you cannot find the inverse. So I want us to graph this and kind of look at what's happening here. So if I graph f of x, so if I just plug in like -2, -1, 0, 1, 2, 3 is going to go off the graph. I put too many things there. So -2 cubed would be -8. -1 cubed would be -1. 0 is 0. 1 is 1. 2 is 8. So if I graph those points, I've got -2, 8, -1, 1, 0, 1, 1, and 2, 8. Okay, this graph that I have just graphed is my f of x. And I want us to think about here, so what the inverse function would look like. So that would just be -8, -1, 0, 1, 8, and then -2, -1, 0, 1, 2. Right, so even if we couldn't find an inverse, we could make a table and switch the points that we have. And so that graph, I'm going to do in green, that would look like this: -8, -2, -1, 1 would stay the same. These 3 points right here would stay the same, and then I'd have 8, 2. So that graph would look like this. So if we think about the point that we're looking at here, we're looking at the point 8, 2, which is right here, right? And we were looking at the tangent line for that. That's what we were trying to find. So the point that corresponds with 8, 2 on the original function would be 2, 8. So 2, 8 would be right here. Tangent line right there would be this purple line right here. So sometimes we might not be able to find the inverse, but I want you to look at what happens if I find f prime of x. That is going to be 3x squared. And if I plug in 2, right, which is our corresponding point, the x-coordinate at our corresponding point, I will get 3 times 2 squared, which is 12. So notice the slope here is 12, and then our slope that we got over here was 1 over 12. Coincidence? I think not. Okay, so we're going to go further with this and look at how we can go through this process of finding this even if we can't find the inverse, because we will have some functions where either we can't find the inverse or they never gave us the equation of the problem in the first place. They might have gave us a table or a graph that we had to deal with. So let's look here. Yeah. All right, so if I've got h of x equals x squared plus 1, okay, for x is greater than or equal to 0. So I would, if I want to do a table here, I do 0, 1, 2, 3, 4, 5. It's probably going to go off the graph there, but 0 would give me 1, 1 would give me 2, I'd get 5, 10, everything else is going to go off of the graph. So I got 0, 1, 1, 2, 2, 5. So my graph of my f of x would look like this. If we wanted to, we could go ahead and plug in our other, we could have, this would be 17, this would be 26, but obviously we can't graph those. Okay, the inverse would be 1, 2, 5, 10, 17, 26, and then 0, 1, 2, 3, 4, 5. So if I graph that in green, then I would be looking at 1, 0, 2, 1, 5, 2, 10, 3. So that would look like this. So this question is asking me for the derivative of the inverse at 5. So the point that I'm looking at here is where my x equals 5. That would be this point right here. And I'm thinking about the slope of the tangent line there. Okay. Now, for this problem, we could find the inverse, right? So we could say x equals y squared plus 1. So we'd get x minus 1 equals y squared. We could square root both sides, which technically needs a plus or minus, but if I restricted the domain to x is greater than or equal to 0 here for this part, do I need the positive piece or the negative piece? Positive, right? And you can see, like on my graph, it's the part above the x-axis, so we'll use the positive. So f inverse of x is square root of x minus 1 whenever y is greater than or equal to 0. And that means we're using that positive. Really don't have to put that y is greater than or equal to 0 because we chose the positive part, which is only going to give you positive numbers there. All right, so we could do, if we're doing f inverse of x is this, I could write f inverse of x as x minus 1 to the 1/2. We got to find the derivative of this. Again, notation is kind of weird. We do f inverse, we put brackets around it, and we put the prime on the outside to show we're taking the derivative here. And so this would be 1/2 x minus 1 to the negative 1/2 times the derivative of the inside. But what is the derivative of x minus 1? It is just 1. So that would be 1 over 2 square root of x minus 1. So if we want to find our derivative here, we would have f inverse prime of 5 is what we're looking for. So we just plug in 5 into our equation. 2 square root of 5 minus 1. That is going to be 2 times the square root of 4, which is 2 times 2. So we get 1/4. So the slope of that tangent line right there, the slope of that red line right there, equals 1/4. Now, let's relate this to the original function. Okay, 5, 2. What point does it correspond to on the original function? 2, 5, right? So 2, 5 is right here. And if I think of the slope of this line, right, original function, I'm just noting this, h prime of x would be 2x. And then if I did h prime of 2, that would be 2 times 2, which would be 4. So the slope of this line was 4. Whereas the slope of the inverse was 1/4. Okay, those are related. That's going to happen every time. So we're going to have a formula here in a moment for that. Now, if we know this always happens, was it easier to do this bottom stuff, or was it easier to find the derivative of h, plug in 2, and then just do 1 over that value? It's pretty easy to take this derivative, right? Whereas the other one's a little bit more difficult. So sometimes we might be able to find the inverse, but it's just easier to use this formula here, which we're going to solidify here in a second. All right. So this one, all right, we're not going to graph this one because graphing e to the 3x is difficult. So I want to know g inverse prime of e squared. Okay, so for this one, we are going to find the inverse, because we can. How do I find this inverse? I switch my x and y's. What do I do to solve for this y right here? Natural log both sides. That will get rid of the e. So natural log there. So I've got natural log of x equals 3y. And then I just need to divide by my 3. So f inverse of x is going to be natural log of x over 3. Or another way to write this is I could write it as 1/3 natural log of x, if that helps you on taking the derivative. As it looks right now, it kind of looks like you need to do a quotient rule, but you don't, because it's just a coefficient. Now that is just my inverse. The question, and I'm calling this f, it should be g. Let's call it g like I'm supposed to. So if I take the derivative of this, the notation looks like this, g inverse, I'm going to put some brackets around it until it prime. So the derivative of the inverse. What's the derivative of natural log? 1 over x. So I'm going to have 1/3 times 1 over x, which is just going to give me 1 over 3x. So if I want g inverse prime of e squared, I will get 1 over 3 e squared, which is a number, because e is a number. So that would be my answer there. Okay, so if you can find the inverse, you can do it this way. But sometimes you're not able to find the inverse. So we need a way we can do this if we can't find the inverse, or if we just don't want to find the inverse. So I'm going to help walk you through a proof for why this always works. Okay? Why it is always 1 over something here. So if you decide to major in math, you will go to school and you'll start off just taking harder and harder math, and you'll be like, yes, this is what I wanted to do. And then suddenly all of your classes will change to proof classes, and you will be like writing paragraphs proving why something has to be true, which is kind of cool because it runs through the logic, but was definitely not exactly what I was expecting whenever I decided to major in math in college. So to prove that this is correct, that this formula we're going to use works, it is a given fact that if f and g are inverses, we know f of g of x equals x. Correct? All right, so I need to know about the derivative of the inverse. Okay? So I'm going to take this known fact right here about inverses, and I'm going to take the derivative of both sides. On the left-hand side, what rule do I have to use? Not product. I'd use product if it was f of x times g of x. This is chain because it's f of g. So for chain rule, the outside function is my f, the inside function is my g. So when I take the derivative of f, I'm going to call it f prime of, leave the inside alone, it's g of x. Then I will multiply it by the derivative of the inside, which is g. So what is the derivative of g? G prime of x equals, what's the derivative of x? 1. Now, if what I'm wanting to know is the derivative of the inverse, right? That's this right here. That's g prime of x. right? Because G is my inverse of F. So if I want to get this formula solved for G prime of X, all I have to do is divide by F prime of G of X. So this formula right here is always true. G prime of X equals 1 over F prime of G of X, where G is our inverse. This formula looks a lot prettier with F and G's, but I prefer the inverse notation myself. Whichever one you prefer is perfectly fine. So I'm going to do the same thing again, but I'm going to use inverse notation. So if F and F inverse are inverses, we know that F of F inverse has to equal X, correct? Right, same thing. We're basically just taking that G, turning it into an F inverse, right? So if I want to do the same thing I just did to prove we're just using different notation this time, I would take the derivative of both sides. So my outside function here is my F, my inside is my F inverse. So to take that derivative, the derivative of F would be F prime of, I'll leave the inside alone, F inverse of X, times the derivative of the inside, which is the derivative of the inverse of F. So that looks like this notation-wise, F inverse, put the brackets around it, prime of X. And this derivative of X is 1, equals 1 here. So this is what we want to know, the derivative of the inverse. And so we would divide both sides here, and we would get F inverse prime of X equals 1 over F prime of F inverse of X. I like it's uglier, but I like this notation better. Somehow it just helps me keep track which one's inverse, which one's the original function. There. But the one with F and G is perfectly fine as well. So this formula right here can be used for derivative of the inverse always. So let's look at using that. Here's an example of a problem where you have to use that formula that we just wrote down. Because you don't have the original equation, right? So we have to use that formula, F inverse prime of X is going to equal 1 over F prime of F inverse of X. Right, so that's that formula that we were going to use. So they give us all this information. They tell us F of 4 equals 7, F of 7 equals 5, F prime of 4 equals 1/3, F prime of 7 equals 2/3. And we are supposed to find F inverse prime of 7. So, if we are looking for F inverse prime of 7, F inverse prime of 7 is going to be 1 over F prime of F inverse of 7. So the first thing we have to find is this F inverse of 7. We've got to figure out what that is. So we did a little bit of this yesterday in notes. What would F inverse of 7 be? What? 4. It's going to be 4 right here. Because if this is my X value on the inverse, it means it was the Y value on the original. Correct? Because we switch X and Y's. So when I see the 7 here, I'm going to look at my Y values that I'm given on the original function. Here, my Y value is 7. The X that goes with it is 4. So we are going to have 1 over F prime of 4 now. And they gave us F prime of 4 right here. So we're just going to plug that in. 1 over 1/3, and dividing fractions is easy as pie. Flip the second and multiply. We'll just get 3 for our answer. So whereas, like on the first problems, we could have done it either way. Like on this problem, we could actually find the inverse, take the derivative, plug the number in, right? Or we could find this derivative, find the inverse of 5, which ends up being 2, and then do 1 over that slope, which is 1 over 4 there. So you could do it either way for a problem like that. But for a problem like number 4, you have to use that formula because you don't have a formula to find the inverse of. Okay, does that make sense? All right, let's do another one. All right, so this equation, we cannot find the inverse of that, or at least not easily. I don't think it's possible, but if it is, it's going to require some extreme measures there. So we cannot find the inverse of this, which means if we're looking for the inverse, derivative of the inverse, we're going to have to use the formula instead, and we can only do it at a certain point. So the first thing that they asked me to find is what is the value of f inverse of 3? So if I have f inverse of 3, that means in the inverse, this is the x. What is it in the original equation? It's the y, right? So I would do 3 equals 1/4 x cubed plus x minus 1. Now, the way to solve this by hand is synthetic division that Coach Wood taught you to do in Math 3. You have forgotten how to do synthetic division, and I have not seen a problem on released AP stuff within the last like 15 years where they have asked you to do synthetic division. Some of the old questions ask you to, but none of the new ones do. So we're just going to solve this on our calculator. So we could spend time doing that, but I think doing synthetic division sounds like Connor's getting 2. Just guessing, checking. A lot of times you can guess or check because they're going to give you small numbers as the actual answer. But just a review of how to solve it on your calculator in case it is something you cannot guess or check. You're going to solve 3 equals 1/4 x to the 3rd plus x minus 1. What do you have to put at the end? Comma x. And it's going to give you 2. Guessing checking is perfectly fine. So if you see it, just go ahead and do it, right? That's perfectly fine. So here x would equal 2. So f inverse of 3 is 2. Okay. But on the homework, it's okay with me if you use your calculator for those. So if I want to know the derivative of f inverse at 3, I'm looking for f inverse prime of 3, which means I will be doing 1 over f prime of f inverse of 3. All right, that's our formula. 1 over f prime of f inverse of whatever value you have. And we just found f inverse of 3. It is 2. So right here, for my f inverse of 3, I can plug in this 2 that I just found. So I'll get 1 over f prime of 2. Now, this one's not quite as easy as just looking up here and seeing what this is. But can we find f prime of 2? It's pretty simple to find because we could just do f prime of x, which is going to give us 3/4 x squared plus 1. And then we could plug in 2. F prime of 2 is 3/4 times 2 squared plus 1, which is going to be 3 plus 1. So we'll get 4. So 1 over 4. 1/4 is our answer here. Yes. Right here, we're taking the derivative of the original because we need to find f prime of 2, which is our original, not our inverse. So we just take the derivative, just straight power rule, and then plug in 2 to find that value. Because a lot of times you aren't able to find the inverse, but you can pretty easily find the derivative of the original, which is what we see here. Okay, we okay here? All right, here, that should be f inverse, not f minus 1, right there. That's f inverse, right there. Okay, so this is our last one. We've got f of x equals 2x to the 5th plus x cubed plus 1. We are supposed to find the derivative of f inverse of x at x equals -2. So this is asking for f inverse prime of -2. And our formula for this would be 1 over f prime of f inverse of 2. So that first thing we've got to find is f inverse of 2. Oh, I'm sorry, -2. So, if I want to find f inverse of 2, what do I do to find that value? 2, so this right here is my x on my inverse, means it was my y on my original. So I put -2 equals 2x to the 5th plus x cubed plus 1. Okay? Connor says we get -1, and I think that looks right. So x here equals -1, and for the sake of time, I'm going to run with it, but you can use your calculator to solve. He's just plugging numbers in his head to see if it works, but you can use solve on your calculator if it's something more complicated. Yeah, if it's odd power, it's still negative. So our inverse, our f inverse of -2 is -1. So that means I'm now looking for 1 over f prime of -1. Can we find f prime of -1 for this equation? We can pretty easily because it's just a power rule to take a derivative, right? So f prime of x would be 10x to the 4th plus 3x squared. And if we do f prime of -1, we'd have 10 times -1 to the 4th plus 3 times -1 squared. Since those are both even powers, it's going to get rid of the negative, so we'll just get 10 plus 3, which is 13. So we'll get 1 over 13 for our answer. We're okay here. Okay, questions? All right. Your assignment for tonight is on page 186, and it's numbers 1 through 10. It is okay for you to use the calculator to solve there if you would like. That'll be perfectly fine. And I said we would go over a free response question, so which one do you guys want to look at? 1. Any other opinions? Anybody else want to argue on that one? Let's see. This is week 7, right? Three. Connor votes for 2 because he likes to be counter-cultural there. Let me look at the solutions real quick, and I'll tell. Three's probably the toughest, I would say. Probably right here. Your horizontal asymptotes are a little bit tricky, but you're just in the derivative limit as x approaches infinity. This is where you're going to get like opposite signs on these. So that is probably going to be the most difficult thing. Also on part D, I used product rule. You can use quotient rule on that if you prefer quotient rule. You do not have to do product rule. And like right here I wrote you technically could stop here. I probably would stop there. Unless there's no reason you need to simplify it more. I did, but you don't have to. Let's look at as much as we can of 3. I think 3 is going to be our best. Alright, so they give you the answer for A. No matter what, you need to make sure you get this as your answer. Even if you don't have the answer, just write down that it's the answer. You might get points taken off if your work is not right, but this is what you have to use to answer parts B and C. In fact, because of the amount of time we have left, I'm going to skip A right now because I think for us it should be, it's not necessarily easy, but it's the easier of the 3 parts. Okay? So, as far as how to do this. So, you're going to do implicit differentiation. You're going to find this is your answer. I'm going to come back to it and do it if we get time at the end. But this is the answer that you get. This is your derivative. So, B says find all points on the curve whose x-coordinate is 1 and write an equation for the tangent line at each of these points. All right. So, the first thing I'm looking for is the points where the x-coordinate is 1. So, what am I going to plug 1 into? X in which equation? The original equation, this x y squared minus x cubed y equals 6. So I'm going to have 1 y squared minus 1 cubed y equals 6. Yeah, equals 6. So this is y squared minus y equals 6. How do I solve that? Subtract 6, y squared minus y minus 6 equals 0. And I'm going to factor. How does that factor? Plus 2 minus 3. Yeah, that'll work. Alright, so y equals negative 2 and y equals positive 3. So that means our point here is 1, negative 2, and our point here is 1, 3. So those are our 2 points. We have to write the tangent line to these equations at each of these points. So for the tangent line, we need a point, which we already have. We just found them. We need a slope, and we need to write the equation of line. How do I find the slope? Plug the values into the derivative. So that's why I could skip this, because I already had the answer, right? So if you're out of time tomorrow, if it's this one, you could skip A and do the other parts first and go back to A if you wanted. But I don't know if I would, because it's probably the easier part. But so I'm going to write here tangent at 1, -2. Let's do that one first. So our wow, that really shrunk. Shrink it a little, but not that much. Okay. All right, so my derivative, the notation you're going to use is like this, dy over dx, such that xy equals 1, -2. And then you're going to plug in 1 and -2. Be careful not to get the x and y's mixed up. So you'll have 3 times 1 squared times -2 minus -2 squared over 2 times 1 times -2 minus 1 cubed. So that is going to be -6 minus 4 over -4 minus 1, so -10 over -5, which will give us a +2 for our slope. And so the equation of that tangent line is just going to be y equals 2 times x minus 1 minus 2. And then we'll go back and do the same thing, which I'm going to do quickly here because we're running out of time. So 1, 3, and you would do, again, the notation for that derivative is you're doing dy dx such that xy equals 1, 3. And so that would look like this, 3 times 1 squared times 3 minus 3 squared over 2 times 1 times 3 minus 1 cubed. So that's 9 minus 9, right? Over 6 minus 1, which is going to give you 0 over 5, which is 0. So your slope here is 0. You can write it like this, y equals 0 times x minus 1 plus 3. That's fine. Or this is just y equals 3. Right here. It's a horizontal line. But, you know. Sometimes I encourage you to just go with this little bit more complicated answer at the risk of making, you know, an assumption of something wrong. We're okay here. All right, so C says find the x-coordinate of each point on the curve where the tangent line is vertical. All right, so if the tangent line is vertical, what do we know? We have a vertical slope. What do we call that? If we have a vertical line, what kind of slope does it have? Not 0. 0 is horizontal. Undefined. And undefined is when we have a 0 in the denominator, right? So I'm going to go back up here to my derivative, and I'm going to set that derivative equal to 0, the denominator equal to 0. If they asked us to find the places where we have a horizontal tangent, what would we do? Horizontal tangent would be numerator equal to 0, right? Because we have 0 over something there. So we got 2xy minus x cubed 2xy minus x cubed is going to equal 0. If you do nothing else, that will get you a point. That will show that you know the denominator has to be equal 0. Now, I can't solve that. It's got an x and a y. All right. So, let me make sure. Let's solve for y. Okay. All right. So, you need to solve this for a variable and plug it into the original equation is what you're going to do. It's substitution. All right. So, you're pretty much going to have to solve for y here because that x cubed is going to make it difficult to do anything with. So, you're going to have 2xy equals x to the third, and then you're going to divide by 2x. So y is going to equal, one of these x's will cancel, so you'll get x squared over 2. And that original equation was xy squared minus x cubed y equals 6. So I know that that has to be true. I know that this has to be true, so I can substitute here. I'm going to plug these in for my y's. So I will have, and in fact, it might be easier to think of that as 1/2 x squared. So I've got x, well, it doesn't really matter. I guess I'll stick with x squared over 2 squared minus x cubed times x squared over 2 equals 6. So for this one, I'm going to square the top, square the bottom. So I'll have x times x to the 4th over 4. Over here, I'm just going to multiply straight across. So I'll get x to the 5th over 2. And so this is x to the 5th over 4 minus x to the 5th over 2 equals 6. It might be easier to think of this as like 1/4 x minus 1/2 x, these are 5th equals 6. What is a 4th minus a 1/2? -4th. So I get -1/4 x to the 5th equals 6. I could divide by -1/4, which is the same as multiplying by -4. So I get x to the 5th equals -24. And then I will take the 5th root of that. So I'll get x equals the 5th root of -24. Since it's 5th root, it does not need a plus or minus. It's just going to be this, and you don't want to try to simplify that. It won't simplify anymore. You're just going to leave it like that. Let me make sure that's what I left it. Yes, that's what I left it as on the sheet too. So you just want to leave it as it is. Okay. Questions? Since these have the same variable right here, they're like terms, so I just did 1/4 minus 1/2. So, 1/4 minus 1/2 will give you -1/4. It's kind of like if you had, it'd be easier if I had like 2x to the 5th minus 5x to the 5th and got -3x to the 5th. But you're just subtracting that 1/4 minus 1/2 there. Okay, questions? I'll give your quizzes back to you at the beginning of class tomorrow. I can't send them with you because I still have too many that have not taken it. But 1 through 10. And then make sure you have your FRQs for me tomorrow. And I'll be here in the morning if you have any questions.